When the laser was first invented, many people thought it was the realization of the ray gun. It may become that. If so, it will be at great cost because although lasers can deliver a lot of energy over a distance, they're not that efficient. Generating a powerful beam means generating a lot more power for the input of the laser. So what makes lasers so uniquely useful? Lasers are valuable as powerful precision devices that can be used for cutting, surgical techniques, communication, and even entertainment. We saw in our unit on radiation how light can be described as an electromagnetic wave. The frequency or wavelength determines the color. Ordinary light, such as sunlight or that given off by light bulbs, is made up of many colors of light. It only takes a prism to separate them. Remember, each color represents a different frequency or wavelength of the electromagnetic wave. Consequently, as the light travels away from the source, the different frequencies interfere with each other, so they don't travel in parallel lines or stay together in a narrow beam, somewhat disorganized. It's something like the disorganized movement of a crowd. Everyone moves with a different step. A laser produces a very organized beam of light for 3 reasons. First, the light is monochromatic. That is, it's only one color or one frequency. Second, and more important, laser light is coherent. All the waves are in step with one another, much more organized. Coherent light is like a marching band. All the elements of the beam are in step with one another. There's no interference. The result is a ray of very collimated light, light that will stay together in a narrow beam over long distances, all without the use of focusing lenses or mirrors. Lasers can produce their monochromatic, coherent, collimated light from several different types of substances. One of these is with gases. When gases are excited by electricity, they will emit light. The color of the light depends on the nature of the gas. Neon, for example, used in signs, gives off a lot of red light. Argon gives off green. Others give off blue, and so on. These gases can also produce laser light if they're excited in a special manner. A neon laser uses a tube of gas that is energized or pumped by electricity. This gets most of them excited. Some of them spontaneously give off photons like a normal neon sign does. Mirrors at either end of the tube reflect some of the photons back and forth inside the tube. As they pass through the gas, they run into other atoms. If those atoms are excited, the photons stimulate or cause the atoms to give off their photons in the same direction, with the same frequency, and in step as the incoming photon. Those two now continue on and stimulate other atoms to emit photons, and so on until a beam is built up. This process is called stimulated emission, and it gives you a laser beam. In fact, that's what the word laser stands for, light amplification by stimulated emission of radiation. Light amplification because the light is amplified beyond that seen in a normal glow tube. Stimulated emission because the action of photons stimulating other atoms to give off their photons releases light. And radiation because that's what light is, electromagnetic radiation. Put it all together, you have a laser, a very useful form of light. Other substances can also be used to generate laser light. Instead of gases, a solid such as ruby can be used as the laser substance, or medium. Here, instead of electricity as the input energy, light from a flash lamp can do the initial exciting or pumping. It's also possible to get laser light from liquids. The choice of the proper medium depends on the color of the beam that's required to suit a particular application. Betty Lawrence is a technician who uses a laser to spot weld parts of the eye. It's called diabetic retinopathy.
Because the eyeball is round, we cannot look straight into the eye and see all portions of the eyeball. So we use a lens that has mirrors on it, and we actually place that lens on the eyeball itself. The laser light is actually focused into the mirror itself, and by that method it is bounced off onto the retina and cauterizes those new blood vessels that are causing the problem in the diabetic retinopathy. When we use the laser, we are using specifically the argon laser for this procedure. The argon laser utilizes a green, coherent light. The reason that the light is green is because red tissue readily absorbs green light. We would use a red light if we were trying to avoid treating red blood vessels or red pigment cells. But we use the argon laser for treating diabetic retinopathy because we are trying to direct that light into those red blood cells and into that red blood. We avoid cutting into the eye and introducing infection. We can treat the eye, the back of the eye, just by means of light.
Since laser light beams travel in straight lines, a laser beam can be used as a level or a reference line that can be used for alignment, in this case, surveying land. The coherent nature of laser light waves enables the production of three-dimensional pictures called holograms. What you are seeing is the image created by an interference pattern of laser light waves. Since light is a form of energy, red or infrared light can be absorbed and turned into heat energy. Infrared laser light is so concentrated it can melt or cut through metals. Because of this, lasers can be used for machining. The advantage of laser machining is that the powerful laser beam can be focused into incredibly small points. Laser light can be pulsed, off and on again, thousands or even millions of times per second. This technique is used to transmit messages over long distances. Glass fiber optic cables are replacing copper telephone cables, providing interference-free communication. Thousands of conversations can be carried simultaneously. Besides sending information, lasers can also be used to read information. When a beam is reflected off the striped label on food products, the so-called universal product code, the variations in intensity of the reflected beam are read as a coded light signal. A more refined version of the same process is the compact disc player. The surface of the disc is etched with a digital code taken from a digital recording. A small laser beam reflected off the disc reads the code. The rest of the system turns the digital code back into music. The advantage of the system is that nothing touches the disc except the light from a laser. There's no needle to wear out, and the laser does not read scratches, so there's no pops or hiss. Precision work takes advantage of the unique qualities of laser light. High-power lasers may become the key to future energy production. The laser beams will be focused on a tiny pellet, raising its temperature to the 30 million degrees necessary for nuclear fusion. Lasers will provide new challenges for technicians of the future.